In this video, we're going to be talking about areas of rectangles. We'll also be talking about three postulates related to area. Often when I ask students to give me the definition of area, they say area is length times width. However, that's a very specific formula that only works in one situation. The general definition of area is that area is the amount of space inside a two-dimensional object. For a square, we find the area of a square by taking the side and squaring it. So side times side, or s squared. This would tell us the number of squares inside the square. Let's take a look at an example. Here we have a square whose sides are equal in length, and it has an area of 75. We need to determine what number that we can take times itself that would give us 75. Unfortunately, 75 is not a perfect square. There's no whole number that we can take times itself that will give us 75. So our answer is that the side is the square root of 75 inches. This could be simplified by pulling out factors that are perfect squares. 75 can be thought of as 25 times 3, and so therefore we could also say that the length of the side is 5 times the square root of 3 inches. Let's take a look at some other postulates related to area. Postulate 18 in our textbook is called the area congruence postulate. If two figures are congruent, then they have the same area. That would seem to make sense. They're congruent, they're the same shape and the same size, so they should fill up the same amount of space. The way we find the area of a rectangle, you're probably familiar with this formula, is length times width, or we could say base times height. So the area formula for the area of a rectangle is A equals BH. Unfortunately, there's very few times where we actually have areas that are rectangles. We might have some oddly shaped areas, like the shape of my living room. These are approximate dimensions for my living room and dining room. We need to use the area addition postulate to help us figure out the area of this L-shaped room. The area addition postulate helps us with this. It says that the area of a region is the sum of the areas of its non-overlapping parts. In other words, we're going to take this L shape and split it up into two regions that I can find the areas of. Now I have two rectangles, and I can find the area of those rectangles separately and then add the areas together to get the total area of the region. I could have split my rectangle by drawing a horizontal line, or split this L shape into two rectangles by drawing a horizontal line. Or I could have split this into two rectangles by drawing a vertical line. Either of those would work. Let's work with the vertical line here, and let's call this region region 1 and this region 2. To find the area of region 1, I need to take the base of the rectangle times the height. And unfortunately, right now, I only know that the total length here is 30. Do you see a way I could figure out the length of the rectangle here? Well, we have a piece up here that's 10. And if this piece here is 10, the other piece would have to be 20 in order for the total length to be 30. So here we have 20. So the area of region 1, or the area of rectangle 1, is a base of 20 and a height of 10, or 200 units squared. In this case, I'd measure length in my living room in feet, so 200 square feet. And for region 2, we have a rectangle that has a base of 10 and a height of 25. So region 2, we would do 10 times 25, and we would get 250 square feet. So the total area for my living room and dining room combined would be 450 square feet. We're going to be doing more work in this chapter with areas, focusing on areas of triangles, trapezoids, and circles. Don't forget to do the survey at tinyurl.